folks, today's show is going to be electrifying, and I mean that literally. We have a FEV, a full electric vehicle in the shop today. Welcome to Tech Garage, presented by rockauto.com.
I got to tell you, I'm convinced that in this Leaf we can get that LS engine, but that's probably another show, another day. This is interesting. The symptoms you've discussed and talked about are not the typical symptoms. So tell us what's going on here.
Yeah, exactly. Well, I was actually driving along and I got this light on here, man, and this is a new one for us here at Tech Garage. A little triangle there, red with an exclamation point in it. Scary, not your check engine light. Found out through the actual owner's manual.
Guys,
yeah.
This almost never happens. Usually he's the guy writing this stuff.
Had to break out the owner's manual. Red master warning light. That was scary. In here says a whole lot of nothing except take it to the dealer. So, you know, broke out the scan tool, figured I can handle it, no problem. Scanned it, a couple of multiple codes, some weird funky stuff going on. Couldn't figure it out. Every time I tried to get in, kept asking me to take it to the dealer. Well, broke down, wrote it over to our Miller Nissan down here, scanned it, come up with the codes, actually talking about some thermal meltdowns. Got a coolant fan problem. Coolant fan, interesting on an electric vehicle.
Absolutely. When you hear thermal and meltdown in the same sentence from a dealer, that's typically not good. And I've seen and used our scan tools. They're pretty good. It's an interesting trend, folks, that you can't harvest the code yourself with your backdoor, backyard scan tool anymore. You got to go to a dealer. So I'm glad you did. But like with any hybrid or electric vehicle, there's some real important safety procedures we've got to honor to get this thing ready to work on. I'm going to go get that going.
Yeah, you know, we're talking about high voltage, but more importantly, high amperage that will kill you. So yes, that cutoff is huge. Once you pull that, take about 20 minutes, let it dissipate. Meanwhile, I got some cool demos to kind of show you the evolution of what happened to hybrids to full electric. Our friends over in Canada from Console Lab actually sent us this cool demo right here on a board so I can show you how it works. Now, it all boils down to how the car is here. You have a motor here. We call this an ICE, internal combustion engine, and then you have these motor generators, one or two motor generators, and it's pretty simple, but we have to know what's a motor and what's a generator. So if you look right over here, I have a simple motor, a couple windings right here, and what I can do is I can hook it up here to positive and negative with a 6-volt source. I can actually show you the magnetism as it starts to spin and it goes around. So my electric motor takes off, and there it goes. Now what's happening, there's a term called counter electromotive force. You remember those old generators? I think Brian's still got one on his car. It actually sends some voltage back up through the system, and that's our generator right here. It actually induces a voltage, and when I spin that, you can actually see it right there. We'll talk about regenerative braking here in a second. But let's come back to our board here, and this is pretty cool because there's different types. You can look at that first graph, and it talks about a series, and a series is just basically like our Leaf here. It's driven by that electric motor. The ICE motor is only used to charge the battery. So what I can do here is I can hold this ICE motor, and I can actually turn it. And if you listen, everything has to spin, and it's pretty difficult to turn because the electric motor is doing all the work. The ICE isn't helping whatsoever, and you can hear it spinning. I'm driving all the generators to the wheels. Now, if you go to the next graphic, that's a parallel. We're going to use the ICE, the internal combustion engine, and the actual motor generators to work. So I'm going to do that. I'm going to take them both, listen to the difference, and watch how easy it is. I can actually spin it. So my ICE motor is helping the actual motor generator. You see that on a lot of hybrids. And I'm going down the road and I'm powering it up. Now what happens with the third one is a series parallel. You get a splitter in the mix. You can use the ICE to charge the batteries, and the ICE can also help drive the wheels. So if I come over here and I drive them all, super easy. I got 2 motor generators running it and everything's going on. Now, you also have another thing called regenerative braking. This is our last graphic right here. If you look at the regenerative braking, I can come over here, I can hold the ICE motor, and what happens is when you start to slow down, you can see. You see it actually pulling? Now what am I doing? I'm actually pulling the actual generators, the motor generators. I'm reversing that polarity and I'm charging it. Well, how does that work? We'll come over here. I can show you. We can actually make electricity, which is really cool. I got the meter set up and I have a piece of wire right here. And this piece of wire, when I cut that magnetic field, I'm actually going to induce a voltage into it, and watch the meter. Here I go. So as I go up and down, I'm actually inducing that voltage. Well, what's happening with the car? Well, the wheels are starting to slow down. We reverse the polarities. We actually start to make that motor into a generator, just like those old starters on the cars used to be, big old generators, counter electromotive force, backup charging the batteries. Right here, if I spin it, there it goes. I'm taking it, I'm recharging the system. Now on our Leaf, it's full electric. And what does that mean? Well, you can see it right here on the graphic. We have a power delivery module on the top with a DC charger, a DC-DC converter. We have the charging system up on top. Below that, we have an inverter, and on the bottom is the whole traction motor. Well, what's going on? Well, all that stuff creates heat. That's a problem. So we have a low pressure radiator system, about 130 degrees. That thing comes on, the pumps start cooling that system. If that doesn't cool, we have problems.
Well, one final mounting bolt in the top of the old cooling fan, but before we got to this, we pulled that master disconnect switch inside. Not hard to get to, 3 10mm bolts, a cover, pull the switch. We let more than a half hour go by, so all of the energy has dissipated. Then came up to the front, pulled the charging harnesses back in. Again, just a couple bolts in here. Nissan's made this access very easy. Pulled them back out of the way. No way they can jump in and get in the way of the project now. Now we're ready to roll. Now, if you're an avid Tech Garage viewer, and I know you are, you're asking the next natural question, which is, how do you know that you got to replace the fan? Well, keep in mind, this goes back to John's trip to the Nissan dealer. They scanned the code. Then they did a final output test of the fan to see if it was in fact working or not. It was not. We couldn't even do that test with a DVOM right here in the garage. That's how proprietary all of that circuitry is. So the problem is the cooling fans. Now, interestingly, both bolts are out. There's a couple connectors over here. I've got them loose. It sits down in a channel in the bottom. It'll lift out in a second. But while we're here, this is the coolant reservoir. Now, we talked about the thermal transfer heat properties. It's all the same as a traditional big system. But look at the coolant hoses. These are the small guys that look like heater hoses, and that's how it flows. This is up out of the way. You can get a good look at it, and I think John went to the rockauto.com shelf to get us a new cooling fan.
Yeah, Brian, I found 2 of your biggest fans, man, right here.
I'll take all I can get.
Well, actually, you actually got the module right here, which is super nice, from rockauto.com, the whole module. We're covering all our bases, make sure that we get everything fixed and fixed right. The whole fan assembly's right here, one piece. Matter of just pulling that one up out of there. Once you get it up out of there.
Looks like it's kind of wedged, so we're going to step it up out this way.
There you go.
Now, you always want to take care of the back of that radiator. If you're doing this by yourself, cardboard on the back of it, but there's no shame in our game. We've got a second set of hands. Let's get this guy in.
Yep, I got it plugged in already, Brian. A matter of just bringing it up and over.
Roll it down, back in the same way it came out.
Yep.
Watching that radiator.
Yep, we got these high voltage wires right here. Let's go a little bit on your side.
Yep, you got it. We're going to roll your way.
All right.
Come on.
Pull these wires. There it goes.
Yep, a little more past that one wire. Good.
Whole module stuck there.
Keep coming down. I like the fact that we're nowhere near the radiator, so that's good. There we go.
Not so
perfect.
Easy. Yep.
2 10mm bolts. Sit that in the channel. That's good. Maybe a little dielectric gel in those connectors. It's down in the weather down there in the road grime. We'll get this thing buttoned back up. It's going to run like a champ.
Well, we got our LS all tore down, and we're ready to make some precision measurements, and we'll do that right after the break.